In recent days, the sun has seemed as if it were waking from a restless sleep. Two X-class flares tore across its surface, releasing waves of energy that swept through the solar system and disrupted communications on Earth. But what if these eruptions aren't the only unusual events unfolding right now? While our attention was fixed on the sun, something far more distant, and perhaps far more mysterious, was happening in the darkness of space. A celestial object arriving from the far side of the galaxy, only the third interstellar visitor humanity has ever detected, was quietly altering its course. Its name is 3I Atlas. After passing perihelion, its closest approach to the Sun, 3I Atlas surprised scientists. It shed a significant portion of its mass, around 13%, and slightly shifted its trajectory. But what intrigued researchers even more was what didn't appear. Even after such a dramatic loss of mass, there was still no clear cometary tail. A wandering interstellar traveler, changing direction, shining brighter than expected, yet leaving no visible trace. In recent weeks, observatories of NASA, the Minor Planet Center, and the China National Space Administration released unprecedented data. The probes Tianwen-1 and Mars Reconnaissance Orbiter observed the object as it passed less than 30 million kilometers from Mars. They recorded a blurred nucleus wrapped in a faint haze, but without the typical stream of dust and gas seen in an active comet. It was a historic achievement, and at the same time, a troubling one. Harvard astrophysicist Avi Loeb said the next weeks will be decisive. If 3I Atlas truly is a comet, it must produce a dense gas cloud that the James Webb Space Telescope will detect during its next observational window. If that cloud does not appear, we may be dealing with something that lies beyond standard physical explanations. This video brings together the latest findings from NASA, CNSA, and independent astronomers to understand what is happening with 3I Atlas, its course change, its mass loss, the mystery of the invisible tail, and the quiet new race among space agencies to uncover its true nature. After perihelion, measurements from NASA's Jet Propulsion Laboratory and the Minor Planet Center revealed something unexpected. The interstellar object had slightly altered its course, a change small enough to be barely noticeable, yet significant enough to alarm researchers. The reason? The observed acceleration cannot be explained by gravity alone. An unseen force was nudging its trajectory, as if something inside the object were releasing energy. Calculations showed that at perihelion this force amounted to roughly 94 kilometers per day squared, and the object had lost more than 13% of its mass. For an object weighing tens of billions of tons, that is enormous, and yet still no tail. The most straightforward explanation is the so-called rocket effect. When frozen gases on a comet's surface heat up and sublimate, the escaping jets of vapor and dust create thrust that slightly alters the nucleus's movement. It's the same principle by which a rocket moves, just on a cosmic scale. But here the logic breaks down. If the comet expelled that much material, where is the evidence? Why do the new images show only a faint glow, with no well-defined tail pointing away from the sun? In his latest analysis, Avi Loeb noted, if 3I Atlas truly lost that much mass, we should be seeing a gigantic gas cloud, impossible to miss. But none of the images taken so far show anything of the sort. This leaves two possibilities. Either the physics of 3I Atlas differs from that of every comet we've ever observed, or the source of its acceleration is something we do not yet understand. Meanwhile, telescopes around the world and probes positioned across the solar system continue gathering whatever data they can before 3I Atlas disappears forever into interstellar darkness. The next observing window for the James Webb Telescope should reveal whether a hidden gas cloud exists, or whether we are seeing the first interstellar object behaving as something other than a comet. But perhaps the most curious development came from China. While NASA was still processing its own data, the Tianwen-1 spacecraft pointed its cameras toward Mars and captured images of 3I Atlas passing just 30 million kilometers away. The camera, designed to image the Martian surface, was never intended for such distant targets. Yet the Chinese team took the risk and succeeded in capturing the interstellar visitor. The images show a blurred patch of light surrounded by a small coma just a few thousand kilometers wide, much smaller than expected. These photos became the first in history to show an interstellar object from another planet, modest in clarity but monumental in significance, a reminder of how closely competition and collaboration intertwine in space science. Loeb commented that he expects even sharper images soon from NASA's HiRISE camera, but acknowledged that China was the first to present the world with a visual confirmation of the interstellar visitor seen from Mars. Tianwen-1 became a witness not just to an astronomical event, but to the idea that the universe is open to anyone willing to observe and ask questions. Yet these new images raised fresh doubts. If 3I Atlas's coma can be seen from Mars, why do post-perihelion observations still show no tail? Is this simply an issue of viewing angle? Or are we witnessing an object that does not behave like a classical comet at all? On November 5th, observatories released the first images taken after perihelion. Once again, a blurry sphere of light, no tail. After losing 13% of its mass, 3I Atlas should have been wrapped in a huge coma. But nothing of the sort is visible. Loeb called this astonishing and troubling. If that much material had been expelled, the dust should have created a dense cloud. Its absence suggests one of two things. Either the particles dispersed too efficiently to form a visible tail, or the observed acceleration came from something other than cometary evaporation. Other astronomers offer a simpler explanation. Perhaps we are looking almost directly along the tail, making it effectively invisible. But even if that's true, NASA's data still indicate real non-gravitational acceleration, meaning the engine is running, but there is no exhaust. This anomaly joins 9 others already documented: the nearly impossible trajectory, the unusual composition, the bluish glow, and now a comet with no tail. While telescopes search for gas signatures, 2 spacecraft, ESA's Arrow and NASA's Europa Clipper, may, for the first time in history, pass through the path of an interstellar object. If calculations are correct, between October 25th and November 6th, they could intersect the region where the tail of 3I Atlas should be. Even if no tail is visible, their instruments could detect ionized particles and subtle distortions in the magnetic field caused by the object's passage. This could become the first direct contact humanity has ever had with matter from another star system. ESA scientist Samuel Grant called this possibility unprecedented. Even a brief dip into the comet's projected path might reveal how the solar wind interacts with an active interstellar body, something never observed before. For science, it's a golden opportunity. For the imagination, it's the modern equivalent of touching something that came from beyond our world. Yes, uncertainties remain. These probes were not designed to chase comets, let alone interstellar ones. But if the improbable becomes real, humanity may, even accidentally, touch a fragment of another star. 3I Atlas is already leaving the solar system. Its light slowly fades like a curtain falling after a performance. But what it leaves behind is far more important than images. It leaves questions. Why does an object that lost 13% of its mass show no tail? How can something so large accelerate without gravity? Why does its orbit align almost perfectly with the plane of the planets? We don't have the answers, not yet. But these are the questions that drive science forward. Before 3I Atlas, we encountered other puzzling visitors: Oumuamua, too light and too fast, and Borisov, the most comet-like interstellar object so far. 3I Atlas seems to combine traits of both: the appearance of a comet, the behavior of something that doesn't fit any known category. Avi Loeb once wrote, "If 3I Atlas is natural, it will be the most unusual comet ever observed. But if it is artificial, it will be the most important artifact in human history." And perhaps he is right, because regardless of the final answer, 3I Atlas has already changed our understanding of the universe. It reminded us that the real mystery is not out there in space, but in how we choose to look at it. If you're following this story, leave a like, subscribe, and enable notifications. Tell us in the comments what you think James Webb will reveal: a massive gas cloud, or only silence hiding something greater. The story of 3I Atlas is not over. Each new image could be the final chapter of this mystery, or the beginning of even deeper questions.